You know that feeling, right? You buy these beautiful, fresh berries, and then 2 days later, they're just done. Or how pasteurized juice just never tastes as good as the fresh stuff. Well, forever it seems, we've had to make this trade off between food that's safe and food that's actually fresh. But what if we didn't have to choose? In this explainer, we're going to dive into a pretty revolutionary technology that might just let us have it all. It's called cold plasma. So, to really get why this new tech is such a game changer, we first have to wrap our heads around the problem it's trying to solve. For more than 100 years, keeping our food safe has come at a cost, a kind of preservation price that we pay in freshness and quality. Okay, think about it like this. On one side, you've got your traditional methods, like heat treatments. They're amazing at killing germs and making food last on the shelf, but that very same heat just wrecks the flavor, it ruins the texture, and it absolutely nukes the vitamins. Then on the other side, you've got perfectly fresh food, which tastes incredible, but it goes bad super fast and, carries a bigger risk of making you sick. And this gets us to a huge question in the food world. I mean, we all want food that's fresh, that's minimally processed, and is totally safe to eat. So, do we really have to keep making this choice? Or is there a way to finally get the best of both worlds? Well, the answer might just be hiding in the fourth state of matter. So, let's meet the star of our show, cold plasma. It's a non-thermal technology, meaning no heat, and it's turning out to be a really powerful and surprisingly gentle solution to this age-old problem. So, what in the world is plasma? Okay, we all learned about solids, liquids, and gases. Well, if you keep pumping energy into a gas, it eventually turns into plasma, basically an energized gas that's just buzzing with charged particles. And you've seen it. It's in the northern lights, it's in a bolt of lightning, it's even what's gloating inside a neon sign. It's a cloud of particles that has this neat balance of positive and negative charges. But here's where it gets really, really cool. There are basically two kinds of plasma. You've got your thermal plasma, like the surface of the sun, we're talking unbelievably hot. And then there's cold plasma. Now with this kind, most of the gas stays right around room temperature. It's only these tiny little electrons that get super energized. And that's the whole breakthrough. You get all the reactive, germ-killing power of plasma, but without any of the destructive heat. So, how does this cool plasma actually clean our food? It doesn't cook it, so what's it doing? Well, it basically creates this kind of microscopic sanitizing storm right on the surface of the food. Let's break it down. The process is actually pretty straightforward. First, you start with a normal gas. A lot of the time, it's just plain old air. Then, you hit it with a strong electric field. This energizes the gas, breaking it apart and creating this potent mix of reactive particles. This storm is then aimed right at the food surface, and that's where the magic happens. And what's in this microscopic cleaning crew? Well, scientists call them RONs. That stands for reactive oxygen and nitrogen species. Just think of them as tiny, supercharged bits of oxygen and nitrogen. You've probably even heard of some of them, like ozone. The key thing is they're all super unstable and just desperate to react with something, which makes them incredibly good at attacking germs. And this is the critical part. These reactive particles are just relentless. I mean, on a microscopic level, they are physically blasting holes in the cell walls of bacteria. They cause their protective membranes to just leak and fall apart. They can even go in and shred the cell's DNA, making it impossible for them to multiply. It is an all-out assault that germs simply cannot survive. Now, this all sounds great in a laboratory setting, but does it actually work in the real world? Let's take a look at the results and see what this could really mean for the food that ends up on our plates. Get a load of this. In one study, a cold plasma treatment on eggshells wiped out 98.74% of E. coli. That is just an incredible level of decontamination, and it was all done without using harsh chemicals or any heat. And it's not just for eggs. The versatility here is what's truly mind-blowing. I mean, just look at this. It works all across the grocery store. In produce, it can make mangoes last longer and even break down pesticides on blueberries. For meat and seafood, it's been shown to slash dangerous pathogens on beef and make salmon stay fresh longer. In the dairy aisle, some studies found it killed 100% of E. coli in milk and stopped mold from growing on cheese. It even works on grains, fighting off the toxins and fungi that make bread go bad. It's just incredible. You know, the scientists who are deep in this research really say it best. They call it a viable and controllable technology that unites food safety and quality preservation. This isn't just a tiny step forward. It's a whole new way of thinking about how we keep our food both fresh and safe. Okay, so if cold plasma is this amazing, I'm sure you're asking the same thing I was. Why isn't it everywhere already? Well, like with any brand new technology, there are some pretty big hurdles to get over before it can go from the lab to our local grocery store. Yeah, the road ahead definitely has some bumps. For starters, the equipment is really expensive and it uses a ton of energy. Figuring out how to scale this up for these huge industrial food production lines, that's a massive engineering puzzle. Then there's regulatory approval. Governments need absolute proof that it's safe. And, of course, at the end of the day, people like you and me need to understand and trust this new process.
So, where does that all leave us? Well, the challenges are definitely real, but the potential of cold plasma is just undeniable. It's so much more than just a new method, it's a fundamental shift in how we approach food. Could this be the technology that finally ends that trade off? The thing that gives us food that is truly safe, truly fresh, and still packed with all its nutrients? The research looks incredibly promising, and it suggests the future of food might be getting a whole lot cooler.